All right, opening to the warm-up. Let's go. 7-2. So 7-2 is all about elimination. So the first three, it literally says to solve using elimination. Of course, by test time, I will let you choose between elimination and substitution, but there will be graphing specifically. So we'll do elimination today since that's what we were practicing. But by test time, you will have the option between those two methods. Okay? The week after next. So like next week is your quiz on Monday, and then we're learning one more section, but it's going to take 2 days. So it's 7-4, Tuesday, Wednesday, review Thursday, Friday, test Monday, the following Monday.
But the quiz on Monday would be
The quiz on Monday is up to what we cover today.
Okay.
Yeah. You're welcome. All right, so number 1, what are we going to do so that we can eliminate the x's or the y's? What's one option? Because there's more than one. I can multiply the bottom by -3. I could also cancel out the y's by multiplying the top by 2 and the bottom by, or the top by 3 and the bottom by 2. You could do either one, but let's do bottom by -3. -3x minus 9y equals -18 added to 3x minus 2y equals 7. So these are going to cancel. -11 equals -11y equals -11 and y equals 1. And then I take and plug it back in. So I'm going to plug it back into the bottom, but it doesn't matter which one. X plus 3 is 6, and x is 3. So 3, 1 is the solution for the first one. Questions on that one? All right, for 2, I would say get rid of those decimals. So if I want to get rid of the decimals, what do I multiply by? 10. All the way across, so 18x plus 12y equals 40. And then you get to choose. Let's change which one, x or y? What do you want to cancel out, the x's or the y's? Pick x. Okay, so we're going to multiply the top by what? -2. These cancel, and I get 34 over here. So does 0 equal 34? No, this is my special case where it would be no solution. So I think WebAssign asked you consistent and inconsistent. Consistent just means there's a solution. Inconsistent means there's not. So that would be inconsistent, whereas number 1 would be consistent. Questions on that one? All right, 3, I would get rid of the fractions. So if I want to get rid of the fractions in the top, what am I going to multiply by? It's got to be the least common denominator. So what do 4 and 8 both go into? 8. So 4 goes in 8 twice. This would be 8 times y, and the 8 and the 8 cancel. I get 6x plus 8y equals 1. And then the bottom, I'm also going to multiply by 8. They didn't need to be the same. So 4 goes in 8 twice. I have 18x. 8 times 3 is 24. And the 8's cancel, you get 3. Then again, pick a variable. You want to cancel the x's or the y's? X. So we're going to multiply by what? -3. -18x minus 24y equals -3. And this time they cancel all the way across. Does 0 equal 0? So this is good. All real numbers. All right, number 4, a grocer sells oranges for 95 cents each and grapefruits for $1.05 each. So you know this is outdated because money's way cheaper then than it is now. I think I like $3.99 on a freaking orange now. You purchase a mix of 16 oranges and grapefruits and you pay $15.90. How many of each type of fruit did you buy? So what are the 2 variables or 2 subjects? Oranges and grapefruits. And I don't care if you do O's and G's. Or you do X's and Y's. As long as, if you're going to do X's and Y's, make sure you know what's what. Because at the end, they could alter these kinds of questions to say something like, how many grapefruit did you buy? Or how many oranges did you buy? Instead of having to ask for 2. So you would need to know which one is which to know which one to answer. All right, so what's true about the total amount of oranges and grapefruits that you purchase? Good. So X plus Y equals 16. And then each orange costs 95 cents and each grapefruit costs $1.05. Total amount of money spent, $15.90. So with a scientific calculator, which is what you'll have, you don't necessarily have to get rid of those decimals. If you still feel comfortable getting rid of the decimals, you totally can, okay? If you wanted to, I'd have to multiply everything in the bottom by 100 because I need to move the decimals twice. So 95x plus 105y equals, and go all the way across your equal sign. That's one of the most common mistakes people make, is forgetting to go all the way across. Now I've got x plus y equals 16. And you can choose substitution, where you solve for one of the variables, or elimination. Since we're on elimination, we're going to practice that one. They're both positive. To me, it doesn't really matter because you're going to use your calculator which one. So let's just cancel the x's out. We're going to multiply by negative 95. So negative 95x minus 95y equals 16 times 95. Negative 1520. And then bring down the top one. 95x plus 105y equals 1590. So these cancel. I have a positive 10y equals 70 divided by 10. And y is 7. So keep in mind with things like these, like I can't buy 7.2 grapefruit. I can't buy 7.5 oranges. So when you get a question that you're actually counting number of tickets or items like this, realize that these should be whole numbers, okay? If you get a fraction, a decimal or a fraction here, then obviously something's wrong. So now if I want to find the number, so y was the grapefruits. There are 7 grapefruits. If I want to figure out how many oranges, I just do 16 minus 7. So 9. 9 oranges. Questions? All right, we're going to jump into 7.3. I promise at some point to review that like headwind, tailwind question from last night. We'll see if we can get to it today. If not, we'll do it tomorrow. But obviously, we didn't have an example like that, and I meant to go over it yesterday before. Basically, if it's headwind, it's coming against you. It slows you down. If it's tailwind, it's pushing you faster. So you have to add it or subtract it from your rate. But if you didn't understand it yesterday, my apologies. Don't forget about it. We'll talk about it before if you're going to see it again on the quiz or test. All right, so 7.3 is multivariable linear systems. It is also has, and it's included in here, but it's partial fractions. So multivariable means 3 variables and 3 equations, just when you thought it couldn't get any more fun. So we're going to have systems with x, y's, and z's. And then the second part of this section is called partial fractions, which we're going to start now, and then we'll finish at a later date. That's called a repeating factor, but we're going to at least start it. But I did not put partial fractions on your quiz because I feel like it's going to be rushed. I will save it for your test, but it will be on your test, and it is on the homework for 7.3 part 1. Okay, so first of all, testing a solution. Now we have an ordered pair. We're not even going to work all the way through this because you'll hopefully understand the point of it. But now you have an ordered pair where it is x and y and z. So in order for this to be a solution, what has to be true? How about, is it just one equation that you have to check? No, you have to plug into each individual equation and make sure they all work, okay? I'm not going to work all the way through it. That's the point, is you can actually take each question and you can check your answers. You have to plug them into all the x, the y, and the z, okay? And then see that they work. Now we're going to talk about actually solving them. There are 2 different types of systems with 3 variables. The first is called a triangle system, and it's because the shape of it is actually triangular. One of the equations will have 3 variables, one of the equations will have 2 variables, and one just has 1. So we do something called back substitution. We take the equation that has 1 variable already solved, and we plug it in to the one that has 2. So if z is 3, then I take 2y minus 3 equals 7, and I solve for y. 2y equals 10, and y equals 5. Now I have 2 variables, so I put the 3 in for the z, and I put the 5 in for the y. And I get 3x plus 5 plus 2 times 3 equals 8. 3x plus 5 plus 6 equals 8. 3x plus 11 equals 8. 3x equals negative 3, and x equals negative 1. So my answers are going in order: x, y, z. Camilla.
Do you get 2 equations?
If it's a triangle system, you will get just like that. One with 3, one with 2, and one with 1. This one, you might have to solve for the variable. Like it might say 2z equals 10, and you have to do something to get to it. But there will be only one variable.
And so it's if you like get it to like that in the triangle.
The triangle ones, yes. Eventually, in a minute, we're going to get to ones that have 3 and 3. But for now, the triangle ones, yes, they will have 3 variables, 2 variables, and 1 variable. And that process is called back substitution, which is important when we get to like matrices. You're waiting on Javi. All right, do it. All right, take the z, plug it in. Y plus 2 times 8 equals 6. Y plus 16 equals 6. Y equals negative 10. Now I get the y.
Oh, no. I might actually be stupid.
You're not stupid. Y minus a negative 10 plus 5 times 8 equals 24. You're making up math, but it doesn't mean you're stupid.
Hey, how'd you get negative 6?
Wait, okay, that's a 12, right?
Yeah.
Oh, wait, it's supposed to be 2 times 8, 16.
Do we get negative 13? Well, we know Bryson did it, but negative 13, negative 10, and 8? Yes? Okay.
Almost there.
Okay. All right, here's the novel. That is the instructions to what we're about to do. Do not let the words scare you. If you practice this, I promise you it makes sense, and it will take less time to actually probably read this slide. These problems take a long time, and they are tedious. I'm going to put it out there right away. If you make one little mistake, and it will probably be with a positive or a negative sign, let's be honest, then the whole thing goes south. So you want to be so careful with these. You are going to take, so these are going to be 3 equations with 3 variables. You're going to take 2 equations at a time. You take any of the 3, and you're going to eliminate one of the variables from those 2, okay? Then from the original 3, whichever one you didn't use in the first combination, you have to use the second time, but you could put it with either of the other ones, and you have to eliminate the same variable. That we call them new ones. Then new 1 and new 2, and then we take new 1 and new 2 that only have 2 variables now. We cancel out another variable. You'll get 1 variable. You'll take it, you'll plug it back into one of the new ones, and then you'll take 2 answers and plug it back into one of the originals, okay? Yes, you've done this before, so hopefully this jogs your memory. No, not all of it. All right, we're going to number it. Let's number it so we know what we're talking about. We're going to say this is 1, 2, and 3. You got to kind of plan a little bit ahead because it will help you out. So I want to see in what 2 pairings I could grab these in so that I can eliminate the same variable twice. So pick. If I pick 1 and 2, what would be easy to eliminate? The x. I could multiply by negative 2. And that's where you're going to make a mistake because you're bringing in a negative. Yeah, but do it if you want to, okay? I would say if you can avoid the negatives, do it. So like if I look at the 1 and 3, there's a change in sign for the x's. I can use those 2, right? And then I would use 2 with 3 because there's a change in sign. Or I could go to the y's and I could pick 1 with 2 and 1 with 3. You could do this a bunch of different combinations. This first time we're all going to pick the same way though so that we don't make a mistake and then try to find it. Kevin.
1 and 3 get y and x and z out at the same time. Multiplying by 3.
No, that's breaking rules.
You can't multiply part by part though. Yeah. Okay, so let's pick what do we want to do? Let's do the x's. So we want to pick 1 with 3 so that we don't have to change signs. So let's try that first. We're going to do 1 and 3. 1 is 2x plus y plus 3z equals 9. And 3 is negative 4x plus 3y plus 2z equals negative 4. Now the goal is to cancel the x's. So to do that, I have to do what? Multiply the top by a positive 2. So I get 4x plus 2y plus 6z equals 18. Be so very careful. If you make a mistake this early, it's just going to keep steamrolling. So then the x's cancel, which was our goal, and I get 5y plus 8z equals positive 14. And we're going to call this new 1 so that we can give it a name later. Good so far. So now which one did we not use? No, we used 1 and 3. So we didn't use 2. We have to use 2. And we have to cancel out x. So we said if we pick 2 and 3, then we don't have to worry about the change in sign, right? So I'm going to pick 3, negative 4x plus 3y plus 2z equals negative 4. And I want to cancel out the x's. So I do what? Top by 4. 4x minus 8y plus 4z equals 32. Cancel out the x's. Negative 5y plus 6z equals 28. And that is new 2.
Does it matter which ones you pick?
As long as whatever you pick first, doesn't matter at all. When you go to pick the second combination, you have to use the one you didn't use, but you could use it with either of the other two. And you have to cancel the same variable. Otherwise, this next step's not going to line up, but you'll catch it. All right, so now I'm lining up new 1 and new 2. New 1 was 5y plus 8z equals 14. New 2, negative 5y plus, what am I saying? Negative 5y plus 6z equals 28. If you canceled out the wrong variable, they won't line up. You'll catch it. You'll be like, shoot, I still have 3 variables here. Now, the goal here is to cancel out one of these variables, and we got lucky because if I just add them, they already cancel. If they didn't, I'd have to change them so that they cancel. The y's cancel, and I get 14z equals 42. Right? And then I divide by 14. Say again. New 1 should be positive 14. Z equals 3. Now what am I doing with it? Plug it back in where? One of the new ones. If you plug it back into the original, you're still going to have 2 unknowns. So it's got to go to one of the new ones. Doesn't matter which one. I'm going to grab new 1. 5y plus 8 times 3 equals 14. 5y plus 24 equals 14. 5y equals negative 10. And y equals negative 2. Now I've got that one. I plugged the into new 1. And now where do they go? Any of the original ones. So like 2 has less coefficients. Maybe I picked that one because of that. It doesn't really matter. X minus 2 times negative 2 plus 3 equals 8. X plus 4 plus 3 equals 8. X plus 7 equals 8. And x equals 1. And I get 1, negative 2, 3. Yes. I think you're next. Yeah. Yep.
When you can plug into any of the new ones.
Correct. And then once you get that one, you can plug into any of the originals. 1, 2, or 3. You're welcome. Z.
I accidentally mixed up on the test and I put like 1, 2 first and then
You'll get perfect credit wrong. Yeah. All right. So, I mean, and I would say most of these are whole numbers, but there can be fractions. Don't freak out, but they won't be like 175 over 2. Like, it's not going to be like that. But you can see fractions here or there. These kinds of fractions are within reason. So your process might be completely different because you might have picked different ones, but we picked new 1, new 2. That was in the teal. And we picked 1 and 2, sorry. And we multiplied number 1 by 4. And then we got 6x plus 13z equals 35. Then you had to use 3, so we used 3 with 1 and multiplied 1 times 5. So I got negative 2x minus 19z equals negative 41. That's new 2. Then on the red on the left, we combined new 1 and new 2 and got z equals 2. I plugged it back into new 1 and got 3 halves for x, and then plugged that back in to the first one, and I got 1/2 for y.
Wait, how did you get 35
There could be a special case with these. If at any point working through your variables cancel out and give you a false statement, stop. It's no solution. If at any point they cross through and leave you with a true statement, stop. It's all real numbers. Okay, so they can happen here as well. Questions on these? So there's only like 2, there's a triangle and then 2 of these, but we need to at least start partial fractions today. So I want to make sure we're good so far. Why are you packing it? Why are you packing it?
Oh, I thought it was 1.
That is correct. That one's negative.
What'd you say?
All right, so this is called partial fraction decomposition, and this is a skill that like you need for calc next year as well, okay? But we're gonna start it this year. So this is what partial fraction decomposition is. Basically, listen so you understand the concept. If I had the right side of this equation, if I gave you 3 over x plus 4 plus negative 2 over x plus 1, and it said simplify, then hopefully you would know I have to find a least common denominator. I would change them so they both have that denominator, and then I would combine them together. And my answer would be what's on the left. That's regular adding, subtracting fractions. We are going the other direction. So you are decomposing it. You are going to take something like that's on the left, and you are going to find out what 2 fractions when added together would give you that. So I'm going to walk you through the process. This is one of those things that you've never seen before, so it's completely foreign. But if you practice it, it's actually quite easy. It's just that it's a completely new concept, okay? This is the full process. When you are writing the partial decomposition of a rational expression, the first thing you are going to do is factor your denominator. And maybe you're lucky and it's already factored and you don't have to do that step. But if not, you have to factor the denominator. Then for each term in your denominator, you're going to split your fractions. So if I had 1 over, and I factored it out, x plus 2 and x minus 1, or x plus 3, whatever it is, there are 2 factors there. So they each get their own denominator, and they each get their own fraction. So it would be something over x plus 2, and then something over x plus 3. However many terms there are, you will have that many fractions on the right side. God bless you. Then we give the numerators a, b, c, and so on and so forth for each fraction. So the first one gets a, the second one gets b. If there was a third one, it would get c. Let's just say it said something like that. Then this is where the wording gets weird, but when you see it, hopefully it makes sense. You are going to compare the individual fraction with the original. And you're going to say, what am I missing from this fraction's denominator to the original? So if I look under A, what term is missing from that fraction and from the original fraction? X plus 3. And so I'm going to multiply that numerator by the one that's missing. Then I'm going to repeat that again for B. I'm going to look at B. I'm going to compare it to the original. That one's missing the x plus 2. I'm going to multiply that times the x plus 2. I added this on, but that wasn't part of it initially. But I would continue to keep going along. And then, so that's step 4. 5 is find the value of x that would make each term cancel out one at a time. So if I solve each of those factors, one at a time, I'm going to plug those values in. And by doing so, it's going to eliminate the other terms, and you will end up solving for just A or just B. And you're going to just repeat that until you've got all the constants. So again, foreign concept. One, that if you practice it is the same step after step. So this just takes practice. skip all the way. So like if you didn't skip the big one, go to, this is example 6. This is what you want to be on. So first of all, what's true about my denominator? Do I have to factor it? Already factored. How many terms? 2. So I'm going to separate this into 2 fractions. And one gets the A and one gets the B. Order doesn't matter because when you go to factor it, you could factor in different order. All right, now compare denominator to denominator. What is the A denominator missing? X plus 5. What is the B denominator missing? X minus 3. So now technically we'll have also changed the denominators. And so all of this will be the same. After that point, we're going to totally ignore the bottom and focus just on the numerators. And I get 6x plus 14 equals A times x plus 5 plus B times x minus 3. And now I'm going to plug in 2 things. And the 2 things are the ones that would be the result of if I actually solved each of these. So if I set x minus 3 equal to 0, I get x equals 3. And if I set x plus 5 equal to 0, I get x equals negative 5. So I'm going to do this twice. I'm going to make x 3, and then I'm going to make x negative 5. Everywhere there's an x, I'm going to plug that value in. So on the left, I'm going to do 6 times 3 plus 14 equals A times 3 plus 5 plus B times 3 minus 3. If you do it correctly, one of those parentheses is going to be a 0 and it's going to cancel out one of your A's or B's. So if I look, 3 minus 3 is 0. This guy is gone. 0 times B would go away. So then I'd get 18 plus 14 equals A times 8. I get 32 equals A times 8. And A equals 4. Now I'm going to go back to my original. And where I had my A, I'm going to make it 4. Then I'm going to repeat that with x being negative 5. 6 times negative 5 plus 14 equals A times negative 5 plus 5 plus B times negative 5 minus 3. Now where's the 0? Next to the A, so the A is gone. I get negative 30 plus 14 equals B times negative 8. Negative 16 equals B times negative 8. And B equals 2. And now I go up to the second fraction and I replace the B with 2. So this is my decomposed fraction. If I found a least common denominator, multiplied by what was missing, and combined these back into 1, I'd get my question. Still with me? Yeah.
When you're replacing A and B with like the new ones, you don't have to multiply them by like.
Nope. That's what we do to get the A and B. But the answer, we just go back to before we multiply by anything. We just do A and B.
Get rid of like the whole numerator.
Yep.
Okay. Perfect. Thank you.
All right. Yeah. All right. So again, it was factored. But if it wasn't, it would have said x squared minus 7x plus 10. And you would have had to factor it.
It's always A plus B, right?
Yeah. So there's 2 terms. A over x minus 2 and B over x minus 5. A is going to get which denominator? X minus 5. B is going to get x minus 2. So I get x minus 14 equals A. X minus 5 plus B, x minus 2. What 2 values of x are you plugging in? 2 and 5. Now let me show you a shortcut. If I plug in 2, which variable is going away? B. Don't even write it. just do 2 minus 14 equals A, 2 minus 5. Ignore the B. If I plug in 5, what variable goes away? A, don't even write the A. 5 minus 14 equals B times 5 minus 2.
Oh, did I mix it up with just
I don't know. You just did, no.
Why does the x negative 5 get a? Wouldn't it be the other way around?
X minus 5. The denominator of x minus 5. Oh,
Like, you can't switch it? Like, how
You
come
can.
X, oh, so
as long as the right number goes over the right denominator, the order doesn't matter.
Oh,
So this is negative 3. A is 4. Negative 9. B times 3. And B is negative 3. So then I get 4 over x minus 2. And the minus goes in between them. Minus 3 over x minus 5. It's not that 4 over x minus 2 plus negative 3 over x minus 5 is wrong. It's just not the way we write fractions.